Household electricity circuits.
Okay, now assume in my room there are three electrical circuits, okay, and there is light. So let me show you how does the electrical circuits works in my room. Okay, the idea is we draw the we draw the power from the main power source, okay, and we put actually those four devices in parallel circuits. Okay. So here I have power socket. Okay. Now here I have a light. Okay. Beside the light I have a switch. So when the switch is off, when the switch is open, the light is off. Okay. Then I have three power sockets. Now, okay. Now, um, the advantage of this setup is, okay, since I have 240 volt in the main power supply. Okay. Now, so each of the component would have 240 volts. Okay. So my power socket would have 240 volt. Also my yep 240 volts here. Okay. So um, yep. Okay. Um, the idea was in household in Australia. Okay. The voltage is 240 volt is constant. However, depends on the power of the devices, the current will be different. Okay. Say if my mobile phone my phone operates at 12 volt. Okay, if I want to charge my phone, I need a 12 volt power supply. So what we do is we need an adapter. Okay, adapt on the power supply, actually transform 240 volt to 12 volt, then I can charge my phone. Okay, so um, so for the light, um, well, it's still 240 volt, but in most cases, there will be transformers. There will be adapters uh, in the light. Say, um, they will downgrade it to whatever voltage it requires. Okay? In every household, there's a fuse. Okay? The fuse is located near. Most of cases, it's located near the main power source. So if the total current gets too big, the fuse will break down and hence break the circuit. Okay, so also beside fuse, there will be a main power switch. Okay? The main power switch will be somewhere there. Okay? So the idea is if we turn off the main power switch, the circuit breaks. Okay? Let's do a summary of this. Okay, so in household electrical circuits, we use parallel circuits. Okay. This is to ensure a constant voltage of 240 volt in every power socket in your house. Okay. Uh, so as a result, okay, the, the voltage is the same. So electrical device of different power usage, they draw different current. Now let's do some math. So an electrical device, for instance, your television, your um, fridge, okay, they use electrical energy. Okay? We know that energy is in joules, okay? But if you check the label on the device, it says something with power. Okay? So it needs electrical energy, but most importantly, it needs um, energy per second. Okay, so the idea was, which is the unit is measured in watts. Okay, the idea was if I have a fridge, Okay, say the fridge is operating at okay, 1,000 watts. Okay, the fridge needs 1,000 joules energy per second to operate. Okay, now let's use the power equation. The power equals to VI. Okay, so if the power should be 1,000 and the constant voltage 240, then we can find out the current. Okay, so it's approximately 4 point something, 4.1. I didn't use a calculator, I just guessed, maybe 4.2. So amps. And okay, once we plug the device into the power socket, okay, the current is going to be 4.1 amps. Okay. Now, similarly, if there is another device, okay, draws only 200, just to make it easy, 240 watts, okay, energy. So if I put this one in the socket, put it in the equation, the current will be 1 amp. Okay, so the current is changing different, well, it's different depending on how much energy does the electrical device draw. Okay, so if you go to Harvey Norman or Dick Smith, you buy an electrical device, okay, most of them would operate at 240 watts, okay, because they designed it so they can sell it in Australia. Okay, yep. So if the voltage of the device is not 240 volts, they need some sort of adapter